Okay, Lady Ada, what is it?
Hello, it's time for show and tell. It's me, Lady Ada. We're here at the Adafruit factory where we do all of our testing, design, manufacturing, shipping, kitting, coding of the electronic goodies that you know and love, all 100 of us. And with me is Mr. Lady Ada and Blink of the Snake. And we're going to have another half an hour of delight as people from around the world come by and show off what they are building, 3D printing, kitting, soldering, whatever it is that they're doing. We'd love to see it. And you might even get a free sticker. In fact, you will get a free sticker if you show off your thing. It's that easy. Let's get off with some Adafruit folks, see what is going on around the Adafruit community. Kicking off with Scott. Let's go, Scott. He's got an overhead going. Scott, what's going on? You're going to unmute.
Hello, yeah. Oh. I've been working on performance. I'm going to scoop Dan a little bit here. So I've got two things going on here. I've got a DVD logo style, just bouncing logo here. And it shows it's slow now because it's only moving 1 pixel every frame. It's not slow because the screen update is slow. I did try a much bigger version of the logo though, and it does slow down. So it's not a panacea. And then the other thing I wanted to show is I don't know how well you can see it.
You got some Celeste action.
I got a Celeste, so if I hit the button, it flickers. And let's see how far I can get in the game. So it's actually playable, which is cool. So you can see
nice. Yeah, you look at you're bouncing.
It's like super quick.
So what's the challenge? It's just hard to play? I mean, it's just hard to play.
Yeah, I think it's actually running a little too fast.
That happened with Nintendo and it was actually kind of funny. Nintendo games are hard already, but then it's like 20% faster than usual.
Yeah, like I thought.
You have to screen too.
Huh?
You have to screen too.
I did. I have been playing it earlier, so I do know the technique. So caution spoilers.
There's a lot of double bouncing.
And I had to turn off the smoke when I boost. So we'll try to get that.
Okay. Well, so what is actually, okay, so it's fun to watch you play games, but what is actually going on? What did you do here?
So this is the original version of, it's really bad to see. You can kind of see it better that way. They prototyped Celeste with the Pico 8 fantasy console, which is written in Lua. And so I took all that code and I ported it to Python. So this is all the game logic's running in Python here. And it loads all the assets that they created for it and everything from the Pico 8 cartridge itself. So yeah, it's a port. It's a proper port of Lua code into Python land. And
then what did you do to make it run so fast? Because last time you were here, it was
yes. Yeah, it was super slow when I was here. What I did is that when the character moves, that's the only portion of the screen that I'm updating. Rather than updating the entire screen every frame, I just update the little bit that has changed, or the multiple little bits that have changed.
Is it fun recreating all of the graphic optimizations that humanity has done in like the late 1980s?
Yeah, well, it is pretty interesting because a lot of the optimizations that happened in the 80s were done where they didn't have a bunch of RAM. So that like the constraints can be a bit different than they were originally as well. I mean, we're running faster than a Game Boy. Like this is 120 megahertz and a Game Boy is only 4 or 1, depending on how you count it. So,
but it's also completely interpreted, not in whatever assembly, right?
Yes, that's very true.
That'd be funny if it was like, okay, you can run Python, but you only get one register. All right, well, this looks great. People can look forward to these optimizations. I know this will be very exciting for people who want to do graphics and gaming.
Yeah, for sure.
For the 4.1 release. And speaking of speed ups and optimizations and more, Dan
also has an update.
Yeah.
Dan, I know you've been working nonstop around the clock.
On BLE, right? Yeah.
Yeah.
So we had somebody in the Adafruit forums who said that they compared the speed of CircuitPython to MicroPython on a similar processor. And it was CircuitPython sort of disappointingly slow when this person tried just a simple loop that was counting up. And so I felt kind of bad about that. And I was like, well, what is it? It shouldn't be, because the base code of CircuitPython is pretty much the same as MicroPython. So I found two things that were actually slowing it down a lot. One is that we do something called background tasks in between, like every time you execute what's called a bytecode, which is like a little piece of the Python program. Very frequently, we go and check to see if there's a background task to do, like, oh, is there something coming on USB, or do I need to refresh the screen, or stuff like that. And the MicroPython implementation this person was trying didn't do the same thing. So it turned out we were actually like using up a lot of time in the background task. And if I turned off the background tasks, then it ran about 3 times faster. So I thought, oh, we have to fix that. So we'll work on that. And then I was comparing MicroPython and CircuitPython, and I found that there was a compile time option that was not set in our code, but was set in the MicroPython this person was using. And I changed that, and then it ran 5 times faster. And this was like changing a 0 to a 1 in one place, basically. It was like, oh my God, that's like
computers are the worst.
5 times things. It was like really surprising.
Or the best.
So just to show you the difference, so I have two Circuit Playground Expresses here. They're running the same program. One of them is running the sped up version, and the other is running the old version. And you can clearly see this is like a rainbow thing, and colors pulse and then they change suddenly. So you can see how one side, like 1, 2, 3, 4, 5, the fast one, and the other one is 1, 2.
Well, twice as fast.
Right. It's really amazingly faster. So this will go into the 4.1 beta release, which we hope to have out in a day, maybe, or less.
Okay.
And people can try it, and your NeoPixel code might start running too fast. We'll see. Okay.
Yeah, and this is for CPU bound stuff. So it's like actually, Scott's working on display optimizations. You're working on CPU optimizations, but it doesn't mean all code will run 15 times faster. Like if you're waiting for the SD card, or if you're waiting for I2C data, that is a different thing that might not speed up. Like in this NeoPixel code, it's actually mostly writing the NeoPixels that takes time. Because you have to wait for them to finish.
Right.
So that's more constraining.
But if you're just doing computation, like it might run a lot faster. So,
okay, cool. All right.
I think confirm graphics, fonts, loading stuff in was significantly faster.
Yeah, and then also if we do like the Mandelbrot calculation, that should be much faster in both ways, both because of the graphics and because Mandelbrot takes a lot of calculations, iterations.
All right, thanks, Dan.
All right, next up, let's check in with Phil B. You can unmute your mic and hello.
There. Okay, I'm unmuted, I think.
Yes.
Good. Let me try the other camera. There we go.
Okay.
Camera. There we go. Anyway, this was an older learning system guide of ours. It's Joy, the friendly joystick controller. It was a Feather-based project that it's a HID controller that you play games on with Raspberry Pi or on your computer, and has a friendly face that kind of cheers you on as you play games. Very fancy, lots of 3D printing and all that. But now we have a whole self-contained, our own little handheld controller, and we can still do, because it has USB port, we can still do the HID game controller stuff. So I have updated the Joy software to run on this now. So you can use the Pygamer, not playing games on the Pygamer, but controlling them on your computer or Raspberry Pi or whatever. Also, as you, she's very soft-spoken. I don't know if you can hear it, but she pew-pews as you click the buttons, kind of at random. So I'll have a guide. I'll try to get that done tonight. It's just a more friendly way of playing games, I think.
Yeah, one of the ideas was kids would be able to, or really anyone, would be able to make their own little avatars for the game controllers. So when they're playing games like, oh, this one's mine, in addition to your avatar in the game on your game controller, it would have that. Also, when you play a video game a little bit too long, Joy would fall asleep or say, hey, it's time to go outside for a walk, and would use a light sensor. So maybe some folks can build upon that and do some.
Yeah, kind of just a start here, but it would be neat, yeah, if it becomes a little more alive over time.
Turn game controllers into Tamagotchis is kind of the theme.
Okay.
All right.
All right. Next up, Noe Pedro. What y'all extruding this week?
Hey,
Hey, guys.
folks. Yeah, we have some 3D printed stuff we'll want to share with you guys. So what should we share first, Pedro?
So we talked about both of these, I think, last week. It's the little crank add-on that you can add to any rotary encoder, and then the snap fit case for the pygamer. So with all that cranking going on, we're like, hey, computers should have some fun too. So here's a USB input. For
Yeah,
the
a little USB crank device. So what I'll do is we'll switch our screens. So maybe we'll put together a little demo and make Code Arcade. So here we go. Can you guys? Yeah, you can.
Oh yeah, so you can go back and forth with the crank. That's a
Yeah.
cool idea.
So it's really, really easy to update the code because it is CircuitPython, and we just have it triggering 2 buttons, just the left arrow button and space bar. So we have a learn guide set up so folks can modify it, and really it can work with any rotary encoder. It doesn't have to be this hand crank. It could be like a flywheel or something. But this makes it really fun because it's like you're
spamming the buttons.
Yeah,
It's
it's
also
kind of like
easy.
a
It's
Gatling
always a little
gun.
tough. You know, the old Arkanoids that they breakouts. They used to have these knobs.
Yeah.
But then used to have D-pads. D-pads and joysticks were actually kind of came later. Originally, it was a knob that you would twist. It was a potentiometer.
And we're going back to the knob. And go back.
Back to knob. Yeah, back to
Yeah.
the classics.
It's full circle knob.
All right, cool. So the people got rotary encoders. They can add crank interfaces to anything they like.
Yeah.
Yeah.
This is really fun to scroll websites as well. Yeah. So a lot
Right.
of cool different ideas that we can do.
Bringing
with it.
the crank back.
Yep. So check it out. We got
We'll
learn
see you
guides.
on next MacBook Air, I'm sure.
Yeah. Alrighty.
And we'll be
Revolutionize.
playing some of the videos and more on Ask an Engineer tonight.
Yep. Excellent. Thanks, guys.
Thank you, Noe Pedro. All right, JP, gaming
Hey.
away.
I absolutely love that they're using CircuitPython to control make code. All the worlds are merging.
Yeah.
Encoder sending USB. So I, speaking of games, have a new game that I'm working on my little pygamer. I'm going to switch cameras and flip it on. This is a game called Trash Panda that I'm working on in Make Code Arcade. And here we go. Let me flip this on.
Okay.
Got our little Trash Panda logo. Then it's going to give you some instructions here. And this is sort of a Rampage-inspired, climbing game-inspired button masher. So the only controls you'll use are the A and B. And depending on which side of the building is safe from bricks that could be falling on your head, you got to mash the button on the other side to avoid bricks and get up to the top. And if you want to see what happens, come join me tomorrow during John Park's workshop. And
No, wait.
but I'm not gonna
You fell down.
Thrilling conclusion.
The thrilling conclusion of this game. What I love is the butt wiggle when you climb. It's just adorable.
It is. Thank you. Yeah, I did just like a 3-frame animation on this little guy, and he does a
It
little.
makes a big difference.
got a
Yeah,
little sound effect in there.
People should check out JP's guide on how to make your sprites move and slight improvements. See, it's like you could just have it go up, but I like the little movement. It gives it a lot more life.
Thank you. And actually, something I'm using in there that's hot off the press is if you hear that sound, that pew sound.
Yeah.
Can you hear that? That is a new thing inside of Make Code that is only available in the Java script, but should be coming to the blocks soon. And it allows you to specify 2 pitches and a duration to do essentially a glide or like a glissando between notes, which is great because so many video game effects are not just like a single note. And I've been using little like trill things to try to approximate it, but that actual pew thing is like vital for these kinds of games, I think. So.
Yeah, that was, it's like if it was easy to do on an 8086, then it was in games.
That's right. Yeah.
All right, well, more exciting games coming out, and
Tomorrow at 4 p.m.
tomorrow 4 p.m.
Eastern time.
Tune in. Yeah.
JP's we making the classics and making new classics as well.
That's right. This is a new classic in the works. Our
All right, sweet.
Go to
Okay, Andy.
Andy, hello,
And
Andy.
Andy's friend.
Hi,
Hi, Andy.
I've got a couple of things. So I've been playing with the Pi badge as well, and I made myself
thanks to the tutorial's little game. And the game is I need to chase my daughter Dorothy around and catch her.
Oh no! Well, she's
Jumping
slippery.
Yeah, she is. She gets away to random places, and if I don't catch her in time, game over.
She wins.
She wins all the time. So that's
this is like take a bath game.
yeah. Get her in the bath. The other thing is, it was just her birthday, so we made her in Tinkercad what we called a dot bot. Her name's Dorothy, and so we made her a curly-haired robot, and we used the LED set that they had that actually just goes inside, and all the kids got to make their own little night lights. So that was fun.
Super cute.
Yeah, a
Love
little bit like Adabot. She likes Adabot.
Yeah, he's Adabot's big sister.
Yeah. Then the last thing is a Pi Portal, and this is a take on the Twilight Zone, episode 6 of season 2, Nick of Time with William Shatner. They go into a diner and they find this penny machine where they can ask it questions. So I use the oblique strategies programming, and when you tap on it, it gives you one of the random references from the show. So it has all of those, and then it'll go back to the front. So a lot of Circuit Python stuff I've been playing with here recently.
This is fun. I love the Pi Portal graphics.
Yeah, you're doing a lot with each one of those. The 4.1 beta that's coming out, that'll even speed up the Pi Portal.
It's so fast you can't even see it update. It just updates instantly.
Yeah,
it's so cool.
That's cool.
Hi.
Hello.
Hello.
Hi.
Okay.
She likes Adabot.
Good.
Hello.
Hi.
Well, email support@adafruit.com and we'll send you out an as seen on the show and tell sticker. Thank you.
All right, thank you, Indian friend.
All right, next up, Zen, and then we'll go to Orlando.
Okay, Zen, what are you up to? You always got cool stuff.
Can you?
Yeah.
Well, you were.
Can you hear me now?
Yes.
Oh, okay. Sorry. So I had a local band want to do something for their album release, and what I did was use a CNC to basically play all their songs. They haven't come up with the graphics yet, and you turn it on.
To the album Malware by battery-powered hooker boots.
That's the name of the band. And it's got a shut up button because I needed it
So you just point
for testing.
It just works the same way. You point it to the
So basically, you select the song, you pull it. And they're a circuit band.
This one sounds great.
Good.
This should be their album. They should just release this. It should be $50 an album, but you get this.
Yeah, go to the merch table. Get one of these.
They want it for the album release, and they're going to give it to somebody as part of the whole album release, and it'll be a lot of fun. And I have actually an output jack, so it can go to an amp and cut off the speaker and play through, real, because it plays the full song, and then the top one plays the entire album.
Yeah.
Hear that. So that's what I've been working on this week.
This is awesome. Nice work, Zen. Well, all that needs is a show and tell sticker. Email support.
I think so.
.com, and then you put a show and tell. This is famous. Maybe people can bid on this. Can raise some funds for the band.
Yeah, I think that's what they're going to do.
Good idea. So it's CNC. I didn't have one of these when I was
There's
a
already a CNC record shop in Williamsburg that just opened a few minutes ago.
Yeah.
And that's how you have to listen to all new music now.
All right, he's next movie. Very cool.
Vinyl is out.
All your friends are very lucky.
That's super cool.
It's a lot of fun.
Excellent work. Well, email support@adafruit. You can get a sticker for that and put it somewhere on there.
Okay.
All right. Next
up,
Orlando.
Orlando. It's good to see you. Happy summer.
I think summer to you as well. So this summer I'll be teaching a instrumentation course for high schoolers. I've been doing this the past 2 or 3 summers, and I talked about this a bit last year as well. So I'm basically making them a little smartwatch. So that's a little circuit board I got courtesy of Oshpark. They were kind enough to sponsor, so that was really cool. So last year, the smartwatch actually went really well. So this year I wanted to upgrade it a bit. And I added a heart rate monitor a little properly, so they can do heart rate on their finger. And these are high schoolers, so I don't know how advanced they'll get, but if they're cool enough, they can get blood oxygen as well, so they can get actually the amount of oxygen in their blood. And so I've added some other things with memory, so they can actually store data long term. Again, depending on sort of their proficiency level. But then other things like temperature sensor, accelerometer to track steps, because people really like doing the activity monitor to track their steps and to figure out when they were sleeping and things like that. So I got to assemble the board and test it just to make sure it does what I think it does. But kids really enjoyed the smartwatch last year, so I essentially just upgraded it a little bit, made it a bit more sleeker. Well, not sleeker, but made it easier for me to assemble. So I actually made the parts bigger because boy, that was really difficult. And so that's what I'll be doing here in the next few weeks.
That's awesome.
The GitHub link, so I can actually put that in the Discord.
Yeah, come by when it's assembled. We'd like to see it. You can show off with the screen.
Yeah, if any of the students want to come on the show and tell me, maybe they get some extra credit for that.
Cool. Yeah, I'll ask. I'll have to clear that with a lot of the program coordinators. So I don't know how that will work out, but I'll bring it up and see what they say.
Yeah.
Oh, I be streaming constantly.
Just scare them. Just say it's how they're good to get their final grade.
That's funny. Yeah, but that's what I'm doing this time.
All right.
I can do a screen share real quick just to share the.
Go for it, and then we'll get out of here.
You guys seen the circuit schematic?
Yep.
Okay, so I'm using SAMD21. This is the popular one, the M0 board. So I've switched over to ARM exclusively these days because it's
a nice chip, man. It's got that DAC. It's got the ADCs.
Yeah, I love it. It has a DAC, has a lot faster, a lot more RAM, et cetera, et cetera. It has a little OLED because you got to have a screen on it. A couple buttons and space for a speaker. The EEPROM and thermistor, and an accelerometer and a heart rate monitor. So it has the circuit for that as well. LEDs for the pulse sensor. So there's an IR and there's RGB because everyone likes RGB. And then typical battery management things. I think actually when I looked at this and compared it to the circuit playground schematic, they're pretty similar. I think the location of the IR sensor, if you guys could put that closer to the light sensor, you can actually turn it into a pulse oximeter device as well.
Yeah.
Yep.
That's cool.
So revision 3, or if that ever actually is within the pipeline.
Yeah, we're still thinking about what we want to do with IR, but it's tough.
If you're using the CMD, you can also maybe do some Python stuff as well. Okay. All right. Well, thank you so much, Orlando.
Thank you.
All right. Well, that's our show for tonight. We'll be doing Ask an Engineer in just about 5 minutes. Thanks for making this the best half an hour every single week for us here at Adafruit. We hope you enjoyed it. Thank you, Zen. Thank you, Scott. Thank you, B. Thank you, Orlando. Thank you, Noe Pedro.
Thank you, JP. Dan.
Thank you, Dan.
We got through everybody in super speed. That was amazing. Thank you.
We will see everyone next week, Eastern time. And Ask an Engineer starts in 5 minutes.
Do you want to trash panda us
out? Play us out, JP.
Play us out. Beep, 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 beep. He's good at this game. Look, he's good.
This is hard.
Only
2 more hearts left. Nope.
Oh, no. Didn't make it.
All right.
Tough game. Watch tomorrow for the thrilling conclusion.
All right. Bye, everybody.
Same Trash Panda time. Same Trash Panda station.